Hi, I'm going to work through this MEI question from AS 2021, Pure in Statistics. Okay, it's the last question on the paper. We've got detailed reasoning. We can see it's worth 9 marks, so it doesn't look very big, but it's worth 9 marks. Okay, so we have this equation of a curve, and we've got a command word here, determine, so we've got to show method. The coordinates, so that'll be x and y. Oops. Of the points on the curve, where the curve is parallel to, so that means it's going to have the same gradient, okay, as the line y is 2x. Okay, well, to get a handle on what's going on, I'm going to sketch it on my calculator first. So we've got y is 3x plus 7 over x, and then minus 3 over x squared. Okay, I'm going to draw it. I can kind of see some of it. It's not ideal. I could look on the view window, and we're interested in when that curve is excuse me, if I zoom out, maybe that'll help. There we go. If I zoom out, I can see some more. So we're looking at when the curve is parallel to the line y equals 2x. So I could actually get my answer now, but I'm going to have to show some method. So if I want to get my answer, I'm going to deselect that, so I'm not going to draw that graph. But I know if my curve is going to be parallel to this, then the gradient has got to equal the gradient of this. So the gradient of that is 2. So I'm going to do options calculate, and I'm going to do dy by dx of this top one, so that's y1. And if I want the general gradient function, so for all x, then I put x equals x. And then if I draw the graph y equals 2, where they intersect is going to be the points, the coordinates, where the curve is parallel to y equals 2. So I can go gsolve and then intersect and see what we get. And I'm going to jot this down. So I've got x is minus 3. And notice this isn't the original curve, is it? It's the gradient. So the gradient is y is 2. That's what we want. And then if we go along to the next one, it's got x is 1. And the gradient again is 2. And then finally, x is 2. And the gradient is 2. Okay, so my calculator has worked it all out for me. I know where I'm headed. Okay. So if I'm doing it by hand, if I want the gradient, I know I have to differentiate this. And if I want to differentiate that, I'm going to have to write it in a format that makes differentiating easier. So I'm going to put 7, x to the minus 1, minus 3, x to the minus 2. And then differentiating that, we get 3 minus 7x to the minus 2 plus 6x to the minus 3. And we know that the gradient of the line y equals 2x, the gradient is equal to 2. So we've got to solve this is equal to 2. Now if I want to solve equations, actually that format is easier. So we've got 3 minus 7 over x squared plus 6 over x cubed is equal to 2. Or 1 minus 7 over x squared plus 6 over x cubed is equal to 0. And now this is tricky, so to make it easier, I want to have no x values in the denominators, so I'm going to multiply through by x cubed. So that will give me x cubed minus 7x plus 6. And 0 times x cubed is just 0, isn't it? Okay, so then I have a cubic to solve. So because this is a determine, okay, then I'd have to show evidence that I know how to solve this. Okay, now I've already got over here some solutions. So if I was thinking of trying out a guess at an answer, I would look at the 6 and I'd think, what are factors of 6? So 1, 2 and 3 and 6. So why don't we try x is 1? So we get 1 cubed minus 7 times 1 plus 6, and I know that is 0, so that means x minus 1 is a factor. Okay, so now we need to do long division to find the other factor. So we're doing x cubed, and then I haven't got any x squared, so I'm going to put that in because it's really helpful in long division if I have a holding space. Okay, and I'm dividing that by x minus 1. So first we think how many x's go into x cubed? X squared. And then we multiply, so we get x cubed minus x squared. And then I subtract that and see what's left. So 0, take away 1x squared. Negative 1x squared is going to give me positive 1x squared and bring down the minus 7x. So what do I multiply x by to make x squared? I multiply it by x. And then I multiply these two together. So we've got x squared minus x. And I take that away and see what's left. So I've got minus 7x minus minus x. So I get minus 6x. Bring down the plus 6. Okay, what do I multiply x by to make minus 6x? Minus 6. And then I'm going to multiply that out, so I get minus 6x plus 6, and if we subtract that, we get a remainder of 0, which is what we'd hope. So we know that when we're solving this equation, we can factorise it, and we get these two factors. So, and then we can fully factorise, and we already know from the calculator before that the solutions of this are would have x plus 3 and we'd have x minus 2. So that would give us x is 1, x is minus 3, x is 2, and then we go back to the question. We've done a lot of work there, and reread it, and it says determine the coordinates. So we need x and y coordinates of the points on the curve where the curve is parallel to that. So I need to work out my y values. So for example, I would substitute this one into the original. So I've got 3 times 1 plus 7 over 1 minus 3 over 1 squared. Okay, now I'm going to cheat and just get my y coordinates from here. So if, oops, exit, there we go. I'm going to deselect the gradient bits, and I'm going to select the original graph. And if I use trace and type in my x coordinate is 1, then it gives me my y coordinate is 7. Okay, if I put x is negative 3, then I get, so I'm just typing negative 3, and I get my y coordinate is minus 11 2/3, so we'll maybe convert that to something a bit prettier. And then finally, when x is 2, then that gives me 8 3/4. Okay, so my coordinates for the final part of my question are 1, 7, minus 3, and then that's going to be minus 33 minus another 2, so minus 35 over 3, and 2, 8 3/4, so 32 plus 3, 35 over 4. Okay.